The next talk in the healthcare panel is about road traffic injury and how data science is used for this particular issue. So we have two speakers in this talk. Sofia is a data scientist at the Department of Surgery and Cancer at Imperial College London. She has a BSc degree in applied mathematics and an MSc degree in advanced analytics, whilst Seema is a general surgeon and a clinical research fellow at Imperial Institute of Global Health Innovation. So both of them are from Imperial. So we look forward to their talk. The talk will about road traffic injury is very important because it is the leading cause of death in those under 30 years of age globally, and it kills a lot of people more than HIV, tuberculosis, or malaria. And we look forward to knowing how data science has been used to reduce the impacts that road traffic injury might have. So I believe they are in the call now and would like to share the slides from their side.
Yep, Sophia, you can share your slides. Yeah.
Great, hello. The slides have gone now. Yep, I can see the slides. Cool, I'll leave you guys to it.
Okay, hi, my name is Seema. I'm a clinical research fellow at the Institute of Global Health Innovation at Imperial, and Sofia Pinto is joining me as well. We're both from the RTIA, which is Road Traffic Injury Analytics for Integrated Data team. Sofia, I think you might have to click the slides forward for me, because when I'm requesting control, I think we lose the slides. So if that's okay, I'll leave it to you. So if we could just switch to the next slide, thanks. So yeah, as Kenton said, it's actually a huge problem, and not many people realise the scale of the issue. And it does, as of over the past decade, it has eclipsed TB, HIV, and malaria. And we're seeing about 1.35 million deaths per year. Globally, and that's not to mention those who are injured and don't die. And it's a significant cause of loss of GDP in many countries, particularly middle-income countries. From a trauma surgeon point of view, and that's what my career is clinically, it's a little bit different from those other diseases in that it's highly time critical. So there's a lot that we could do to save lives and reduce disability if we could just know a little bit more about what's going on and where and how and why. Because that way we can both do preventative measures and improve the quality of post-crash care and get people alerted and active a bit faster, and that directly does save lives. Next slide, thanks, Sophia. And in response to sort of what Kenton was saying, what has been done with data science is frankly not much. One of the biggest problems that we have globally is there just isn't that much data around road traffic collisions or the injury. The UK is considered one of the world leaders in the data collection they have around road safety, but even we have significant trouble. So this little map diagram here shows you what we've got in the UK, and we're using London as a test case. We see it's fairly fragmented. So you've got Stats 19, which is police data. It tells you about the collision. We've got some pre-hospital data from the ambulance service, which tells you where people are taken to, but the rest of it is actually in paper form, and you can't access it in terms of the clinical data. We've got national hospital data, which we also call HES. That's great in that it's national, but it doesn't give you much granularity in terms of what's going on with these patients in terms of their injuries and the outcomes. And finally, we actually have a specific trauma database, but that only takes information about those who are most severely injured. So drawing up this picture of what's actually going on from the point of collision right the way through to outcome is actually very difficult, even with the gold standard data sets. Now, the further issue we have with those, especially in middle and low-income countries, is, first of all, often they don't exist, and they're even more sparse. But even in the UK and high-income countries, we have an issue around a time lag between those data sets being collected and being made available. So again, as a working clinician and people in the field, we struggle to know what's the latest in terms of the patterns of what we're seeing out there. And even when we do try and link this data together, we're not getting a complete picture. for the reasons that I've mentioned. Next slide, please, Sophia. And so I turn to this idea which we have some experience of in other forms of disease in global health. So for infectious disease, we've actually started looking at novel sources of data taken from social media, news media, mobile data, and that's been used pretty successfully actually to detect disease outbreaks and their spread in the context of things like influenza, Ebola, and Zika. And that's right across various continents, so the Americas, Africa, and Asia, as well as high-income countries. Next slide, please, Sophia. And we thought that this might be something that we could apply to road traffic collisions and injury because they're actually more stable than the infectious diseases in many ways. And we've got additional data sets that come in the form of those taken from road navigation apps, so traffic navigation apps. So we're primarily focusing on, from that particular category, Waze, because users from Waze can directly input and report an incident if they see it. So that is a direct form of crowdsourced data. Tweets, again, there's been some work around using tweets for traffic, and we want to modify that a little bit. And we're fairly agnostic in our use of news media, and we want to validate these data sets against the gold standard data that I went through in the previous slide. I'll just pass on to Sofia to tell you a little bit more about the barriers that we've been facing.
Hello, everyone. So now that Sima gave you an overview of the project, we'll talk about the data collection phase, which is the one we are finishing now. So since we didn't have a lot of data analysis to show you, I thought of talk to you about the main difficulties that we faced in the data collection phase, and give you some insights, especially to those of you who want to work with Twitter and use media data and haven't done it before. Starting with Twitter. Twitter provides data for free through their free APIs, but there's also content if you pay for it. So regarding the free APIs, the two most common endpoints are search and streaming. With search, you can go back 7 to 10 days to get a sample of data, and with streaming, streaming provides you data in real time. And per second, you can get up to 1% of what's being tweeted in that specific moment. And you can think, oh, but 1%, that's not a lot. It is a lot of data, 1%. If the tweets that you want to retrieve, the tweets on your topic, if these don't surpass this 1%, you can actually get all of the data that you want to look at. Now, if you want to retrieve tweets from more than 10 days ago, or if the topic that you are looking at is a hot topic and there's more tweets than the 1%, then you need to pay for it. But I would advise you to always extract data from one of the free APIs first. It can give you loads of insights and help you creating the rules for your paid tweets. Now, as with everything, this type of data, it has cons and challenges. And one of the main cons is that only 1 to 2% of tweets are geotagged. And if you want to increase this number, you actually have to look into other fields, such as the text of the tweet, and also the user profile location. Regarding challenges, and specifically about road traffic collisions, there are some possible biases in terms of location and level of injury. And in general, Twitter data is biased to some age groups, for example. So we need to take that in consideration. And as you might imagine, extracting measurable information from free text fields, it's not an easy task, and also to validate this against gold standard data. So another type of data that we are using is news media data, and I have the feeling that when people think, okay, I need to use news media data, they straight away think, okay, let's go scraping. But actually, the first thing that you should ask yourself is, what information do you need from this type of data? Because if you only need the number of news on a given topic, you can actually use MediaCloud and not scrape. So MediaCloud is an open source platform, and it's basically a massive database of news from the world. And one thing that you can get from MediaCloud is the URLs to news on a specific topic in a given time frame and from the sources that you want. So in this case, you can get the number of news without scraping anything. Now, if you really need to extract information from the news full text, there are 3 ways you can do this. The first thing you should do is check if your source has an available API. For example, The Guardian has the Guardian Open Platform, and the New York Times also provides access to their APIs. There are also news aggregators, but these are usually paid. But the good news is that if you're a student at Imperial or if you work at Imperial, Imperial provides you with access to Factiva, which is a database of news. And there are other news aggregators. Another example is the News API. But the thing with the News API is that you can only go back 1 month. Okay, you don't have access to APIs, you don't have access to news aggregators. Let's go scraping. But before doing that, check the terms of service. This is something that you should always do. You should always check the terms of service because some websites are very specific in what they want and don't want you to do. And you should also check the robots.txt. So every website has a robots.txt. So as you see here, this is for the Telegraph. And this path tells you where your robot is allowed and disallowed to go. So you should always check this. Now everything is okay. You can scrape, you're allowed, you've checked the terms of service. It's always good to get the URLs from the news in advance. You can get these either from Media Cloud or from RSS feeds. Then the next step is to code a respectful scraper. You should always implement delay between clicks, identify yourself and the purpose of your scraper in the header, and if possible, you should operate on off-peak business hours. Now, news media data is better organized than Twitter data, but it's still text. So there's a challenge here in analyzing this type of data. And as with the Twitter data, if there's a news article on a crash, it's probably because the level of injury was high. So these are some of the cons and challenges with this type of data, and I will pass over to Sima again.
So broadly speaking, whatever data we're using, the primary issue that we are going to face is this issue around linkage. We have I've written down a number of these here in the tree that I've drawn, but they're broadly down to ethical, legal, and technical. Technical really is to do with, we don't have a common identifier across these data sets, so we're going to have to do a degree of fuzzy matching, and what parameters we use for that will vary, and we have to experiment with. And similarly, the degree of confidence we need to use as a threshold before we say this is actually going to be used as an event or a collision, and added to the data that we look at. So that's already a huge challenge, and then we have to consider the ethical legal framework. So we talked a little bit about the legalities, but from an ethical point of view, we really have to be very careful about the potential for re-identification of individuals. That's a massive no-no, both in terms of health research, but also just under GDPR. So you have to remain compliant with that, and we've had to go through a fairly stringent ethical process to allow the project to proceed with the data sets that we're using. And then just the final slide, Sofia. So really, we're going to be at a very basic level validating each of these novel data sets to see, what is the efficacy of each of these at identifying the location, timing, frequency, and severity of the collision. And if that's good enough, we can use that data to create some historical heat maps. Sorry, my cat is trying to join in. And if we can use some of the patterns of risk that we've identified to forecast what might be happening next. The last aim is probably the most difficult to achieve, and we may not be able to do this, but situational awareness in real time. So being able to say there's been an incident just now, it's likely to be this significant, i.e. it is enough for an ambulance to be sent in that direction, or at least to be put on standby. That is potentially happening in other parts of the world, primarily the States, but they have data sources far more rich than this, just because they have, for example, more people using tweets and ways. But it may well be coming to places like London and elsewhere on the globe as well. So yeah, that's our project, and thanks so much for your time and attention. And if you have any questions, just pass them to Kenton.
Hi, thank you, Sima and Sofia, for your talk on this very relevant issue, and about how you guys use data sources from various different locations and process it, or maybe do web scraping respectfully. to get like various outputs that are really meaningful for the healthcare scene. Personally, I was just wondering, like, are there like, have you found some surprises in this project, like some surprising insights or some something that you didn't expect whilst doing this project?
I'll maybe say a little bit first, and then Sophia can probably add her a little bit. So it's actually, this is a real, I'm sure like the other panelists for our session, like this is actually a real world project. And we've had to, a bit like our previous speaker was saying, that we've had to make sure that people in charge of policy have been engaged right from the beginning, because it's all well and good doing a data science project, you know, with a limited data set, without necessarily consequence or without your findings being rolled out into the real world. But it's not going to go anywhere, it's not going to change the world. So we've had to do that. But the biggest surprise, I think, and it's not really a data type surprise, it's more like if you're going to take your data science work and apply it, the amount of, I guess, resistance and barriers you have. People love the idea, but when it comes to actually, you know, getting all the agreements and stuff, there's a lot of dragging feet, there's a lot of, you know, negotiations you have to make, and there's a lot of bureaucracy. So it's that interface between real world and the lovely sort of safe space that we've got when we work with our own data, trying to get insights from it, and trying to negotiate that, I think, is probably one of the biggest challenges. Sophia, I don't know if you want to...
Yeah, another big challenge is the amount of data that we have in hands. For example, from Twitter, if you use the streaming API, of course, you'll have to use keywords, but not all of the tweets that you will get concern to road traffic collisions, but these are a lot. And to work and to analyze these is a big challenge. But as I was saying, we just finished our collection phase. So I guess more insights and surprises will come once we dig in and analyze this data.
Great, thank you. So we have another question from Griffin. The question is, that was really interesting, and what's the next stage for your project?
Kind of as